Good day everyone, I am Kitor Graida, ID 123, and today I will be teaching you FNDMATH LQ4 problem number 2. So, this is an example of composite inverse trigonometric function as previously discussed in the first video. So, if you haven't watched the first video, I highly suggest you to watch it first so that you may get a deeper understanding of what composite inverse trigonometric functions are. So we will try to evaluate it. What's the value of cosine times this expression? So we know that whenever we get an trigonometric function, let's say tan of angle, we get its corresponding value. Sorry for the handwriting. We get a corresponding value. So let's say tan of pi over 4, we get 1, right? Because tan 45 degrees is just equal to 1. However, if we get the inverse trigonometric function of tan or arctan, this is just the same as arctan, tan raised to negative 1, we will for input a corresponding value so that we will get an angle. So it's just the opposite. These two are just opposites or inverse functions, if we might say. So if we get, let's say, 1 inverse tan of 1, we get a corresponding angle of pi over 4, right? So using this logic, we can find a corresponding angle which leads to a value of negative 12 over 5. So we can assign that angle to theta, right? We get theta because angles are expressed in theta. So how do we find it? So, well, we could try to do imitate a triangle, a reference triangle in the Cartesian plane. So first draw a Cartesian plane. So sorry if it's not straight, like that. So we know by the x table or x-axis as we call it, that all trigonometric values are positive in the first quadrant. Only cosine and its corresponding inverse function are positive in the fourth quadrant. Tangent is positive in the third quadrant, and sine is positive on the second quadrant. Well, we can see here that the inverse tangent function of is negative 12 over 5. So what quadrant would bear a result of a negative tangent function? Well, it's the second quadrant and the fourth quadrant. But that inverse tan function only has the range of negative pi over 2 to pi over 2. Why? Because if we input tangent of pi over 2, remember, the corresponding range for the inverse tangent function is the result when you apply it to its inverse function, the tangent function. So when we try to input tan pi over 2, that's undefined because that's simply so sine 90 over cos 90, which is 1 over 0. So that's undefined. So its range is limited to these two ranges, two values. Between these two values, I mean. So negative pi over 2 to pi over 2, that's just 90 degrees to 270 degrees. So between these two quadrants. So since the tangent function is negative, it can only lie on the fourth quadrant, right? Because the inverse tangent function only has a range between these the first and the fourth quadrant, not here, could not lie within these planes, and it's also negative. But since all trigonometric functions are positive in the first quadrant, it can only lie in the fourth quadrant. So I hope you understand that. Now we could draw our reference triangle in the fourth quadrant. So let's say for an angle of theta, in the fourth quadrant, since tangent is just tangent of theta, just opposite over adjacent, we get opposite, which is negative 12. So we get negative 12 over 5. So this just opposite is negative 12 over the adjacent side, which is 5. We can solve for the hypotenuse of this triangle using the Pythagorean theorem, which is, remember, a squared plus b squared is equal to c squared. We could further simplify it as the square root of the sum of the squares is equal to the c, or the hypotenuse. So let's say we can actually assign any value to a since its addition is commutative. So let's just say 5 squared plus negative 12 squared. So this corresponding square root, so just 25 plus 144. The square root of 169 is equal to c. So 13 is equal to c. So we can just assign it as 13. So we have already completed our reference triangle, but why did we do it in the first place? Because we don't know what the value of theta is. As far as we know, theta could be, let's say, 30 degrees, 30.69, or any other value that would bear negative 12 over 5. I can do it with a calculator, but since we are not allowed to use this time, well, we can only do this using this method. So theta must be equal to negative tan, inverse tangent of negative 12 over 5. Because if you remember, an inverse function, when we input a corresponding value, we will get an angle. With angle, we mean a theta value, okay? So we just substituted it because we don't know what the theta is, right? We don't know what it is. So moving on. So we get, further simplifying it, we get cosine 2 of theta. So if you remember, we have a trigonometric identity for cosine 2 theta, which is just equal to cosine squared theta minus sine squared theta. Sorry for the poor handwriting. So, sorry for my allergies. I hope you've taken your medicines today. So cosine squared theta minus sine squared theta. So you see, how do we get these values? So using our reference triangle. So we know that tan theta is just equal to negative 12 over 5. We could using the reference triangle, we could get cosine of theta, which is just adjacent over hypotenuse, and sine of theta is just opposite over the hypotenuse. We get negative 12 over 13, and cosine of theta is equal to 5 over 13. So inputting these values, cosine squared of theta is just squaring these values. So 5 over 13 squared minus 12 over 13 squared. So we get 25 over 13. Oh wait, I'm sorry, I forgot to square. 169, I mean 169 minus 144 over 169. So we get a final value of 119. Wait, 119. Yeah, 119 over 169. We cannot further simplify it. Yeah. So this is the final answer. So it might look a little bit too hard to absorb at first, but we'll get the hang of it as we proceed with the next problem. Problem number 3. So whenever we get this kind of value, so if you're confused why we cannot cancel it out, because cosine and tangent are not the same functions, we cannot cancel it out. They're not the inverses of one another, so we cannot cancel them out, right? So we need to solve it, all right? We need to assign a theta value so that we can create a reference triangle and use that reference triangle to solve for the values. So that is all. Thank you for watching, and subscribe and share it to your friends. And you can scan the QR code for more to book a tutorial session with us. And I hope to see you all in the next video.